Hi, we are Evan Kulik and Scott Larson from UT Austin here to talk about our factory robot prototype, which can move chess pieces. The main objective for this project was to use TI's new PGA 411 resolver to digital converter in order for the robot to know its position at all times. In addition to the PGA 411, our robot design utilized the TM4C123 microcontroller and the DRV8833 motor drivers from TI. For this project, our budget was $1,000. Because of budget constraints and a lack of mechanical expertise in a team of all electrical computer engineers, we purchased the AL5D Robot Arm Kit from Robot Shop. The key feature that allows the robot to know its own position is a piece called a resolver. A resolver is made up of two components, a stator, which does not move, and a rotor, which is attached to the motor shaft and fits concentrically inside the stator. When voltage is applied on the rotor winding, a voltage is produced in the stator winding, which corresponds to a sine and cosine component. The ratio of the components calculates the absolute angle of a motor shaft. Using TI's PGA 411 resolver to digital converter, our system can take the voltage outputs of the resolver, calculate an angle, and send the angle information to the TM4C123. The TM4C houses the main logic for motor control and handles the interfacing that allows commands to be sent to the robot. On the TM4C, we use the PWM module to control all 5 servo motors on the robot arm. In order to amplify the PWM signal voltage from the microcontroller to the operating voltage of the servo motors, we use the DRV8833 motor driver.
As you can see in the system block diagram, there are a number of different components that make up our design. The most central component is the microcontroller unit, which as we mentioned is the TI's TM4C123. The microcontroller reads in an input from the software that contains which chess pieces it is supposed to move. With this information, it is able to calculate how to move the motors to achieve this task. The microcontroller then sends these motor control signals using the PWM through the motor driver, which amplifies the signal and passes it to the motors to execute. With the motors moving the arm, the resolver outputs its sine and cosine readings to the PGA 411. The PGA 411 then calculates an angle from these readings and sends it back into the microcontroller to be used in the motor control logic.
Because the resolver is not a hobbyist's typical design component, the team had to design custom 3D printed pieces to attach the resolver to the robot arm. One piece attached to the frame of the arm and held the stator of the resolver in place, and the other piece was a shaft extension to attach the rotor to. With this setup, our resolver was able to accurately read the angle of the shoulder joint for the robot. Here you can see the entire system at work. With the graphical representation of the chessboard on the screen, the user is able to pick up and move any of the chess pieces to a legal position, and the robot will mirror the movement on the physical chessboard. The robot's movement is divided into multiple parts. The movement is dependent on whether the player is only moving a piece or is also capturing a piece with their move. If the player is capturing a piece with their move, the robot will first move to the captured piece and remove it from the chessboard. It then returns to moving the original piece to the desired position.
The microcontroller is able to determine how to move the motors based on a lookup table. The lookup table contains an entry for each of the 64 coordinates on the chessboard. The software sends a command to the microcontroller composed of 2 coordinates and a flag as to whether there is a piece captured in that move or not. The first coordinate is the coordinate of the piece the player wants to move, and the second coordinate is where the player intends the piece to move to. When the microcontroller receives a command from the software, it uses the lookup table to find the entry for the 2 coordinates. Each entry is comprised of 4 values. Each value is the determined PWM value for either the base, shoulder, elbow, or wrist motor that moves the robot arm to the desired position on the chessboard. In this motor control scheme, the resolver is used as a check to make sure the motor is moving to its correct position. The PGA 411 is able to give the microcontroller the angle of the motor at any given time. When the motor finishes its movement, we compare that angle to the angle that we want the motor to be at. If there is a discrepancy larger than our tolerated error of 5 degrees, we move the motor a portion of the measured error so that it will always be at the correct position to pick up and move any chess piece.
We believe this project to be scalable to large applications, such as an assembly line in an industrial setting. There is also a lot of expansion available with adding resolvers to the robot arm. Having a resolver attached to each motor would improve the accuracy of the robot as a whole. We would like to thank Alex Shorman, our Texas Instruments sponsor, our faculty mentor, Dr. Vijay Reddy, and the University of Texas at Austin for giving us this opportunity. Thank you.